Alright, time for another DraftPhysics.com, DebatePhysics.com, also video presentation. So, I was linked to another video by, gotta think of the name, Analytical Sentient, to this Chris the Brain channel, and a video on photons. Yeah, it's one of those weird kind of channels that only has a couple of thousand, well, it's 17,000 subscribers. And, you know, it has a video that has 300 and something views, 300 and something thousand views. But the average is more like 2. So this one's got 67 so far. Whatever reason it's in the cycle, you know, of viewability by YouTube standards, it just really is so annoying. So anyway, so he's trying to get an audience, and seems a reasonable enough fellow, all that kind of crap, but yes, it's still crap. He's pretending to be an outsider, you know, viewing the physics and saying, oh, look, this doesn't quite make sense, that's not quite right, but it's all inside the same container of choosing a side between wave and particle, which is partially, sorry, there's something on the screen. Anyway, which is partially reasonable, but the arguments are just poor. So it's almost like me saying I'm a particle person because Feynman said so. And then I'd have to accept Feynman's kind of lame explanation for why, which is, well, the clump detector says it's a clump, you know, which is sort of really cheating, right? I mean, of course the clump detector says that. You know, so it's not a great argument, where I think I can make a much better argument. All right, so I could tell this guy, hey, look, Chris, watch a few hundred of my videos. Well, that's not going to happen. You know, so, you know, the simulation video on debate physics would be one to watch about charge, because that's sort of the subject when you get to photons and how they're created, is that you sort of have to have some rational understanding of what field is getting irritated by motion of electrons, and how that field can be. So I'm going to start. So he's got an hour and a half video, right? I'm not going to play an hour and a half video because, you know, that'll take 5 days. So there's a point here in the video where he's getting to the point, okay, versus just kind of explaining how, well, everything the rest of the world says is sort of bullshit. So, but he's using, you know, 3 red, 4 brown, or whatever the hell that stupid channel is. You know, a big math channel, frankly. And the simulations are nice. Well, they're not simulations, right? They're animations, right? There's like an illustration, an animation, and then a simulation. And these are all animations that don't have to obey any rules at all. Anyway. So, yeah, so I'll just play it, and then I'll get into this whole... I mean, it's a fundamental mistake, or, you know, in the whole description of reality that just, it's just, you know, it really shouldn't be made. It's so bad, frankly.
You can see that when an electron moves...
I probably have to fix the volume. Okay. Probably have to. Probably have to. Oh, sorry, I should have paused for that. Yeah, my bad. Continuing.
The change in the EM field produces a full expanding sphere of changing field vectors.
So his basic argument is that, you know, you can bounce something up and down over here, and somehow the thing over here will start bouncing up and down because they're somehow tied to each other with little steel rods or something. I mean, it's just, if I take something in a swimming pool and I move it up and down, I'm not going to make much wave going that way. There's not going to be hardly any pressure going that way, right? The pressure is going to go up and the pressure is going to go down. And yes, the down pressure has to go sideways eventually. And same with the up pressure in the sense you're going up in gravity, blah, blah, blah. But there's going to be very little motion this way. So this way, this is only going to, it's only pushing that way. That's the only place it's pushing, right? It's pulling the other way, so to speak. but it's a push. You got to push into the field. This action compresses the field of BBs. And frankly, that's closer to the truth, Chris. It's BBs. The energy is in the field. The little bits in the field have the energy. The matter is just getting pushed around by the field. Okay, and every time it's pushed by something, that means it has to move, and it moves slower, okay, than the thing that pushed it. Anyway, so I'll illustrate this further, but this is fundamentally dishonest, the whole way they're trying to describe this idea of this oscillating this way, creating energy that way. It just doesn't happen. Electrons on a surface are doing this. That's how they're making photons. They're compressing the force in front of them, and then they're expanding it. So they're saying, 10 bits per inch now, 4 bits per inch, 10 bits, 4 bits, 10 bits, 4 bits. That's what's happening. That's the frequency.
You could also see that those vectors are most significant in a ring around the center where they are parallel
so
to
look
the
at
electron's
the,
motion.
you really can't see it, but this has got arrows going up and down, and the arrows going up and down just keep moving through space, going up and down. How could they? No, they're not going to do that. When you move something, it moves, even if I said a fluid, right, and I move something up, you know that there's arrows going this way and pressure going this way and pressure going this way. And they don't just keep going like this through space. No, they just keep going. That's it. It's done. The arrow continues to move. It doesn't stop and then go back and then stop and go. It doesn't do any of this. I can't make the push up go into something upping and then somehow it goes back down and then it goes back up and then it goes up. I can't make anything like that. It's impossible. It's just absolute nonsense. This jiggling somehow creates, when I go up, that somehow I make an up arrow, and the up arrow just keeps going. I'm an up arrow, and yes, I'm just going up, but I'm going this way for some reason. There's no reason for it to go this way, right? What's the momentum here? What's the cause? So I have more than one momentum. I have a momentum doing up that somehow can't go anywhere, so it just says I'm going up, but it never does. And then I have a momentum going sideways. I mean, nothing does that. This isn't simulating anything real. There's no ether, there's no anything that can do what this animation is doing.
You can also see in this clip that the emitting and receiving electrons are moving parallel to each other. Their electrons don't have as much personality as ours, but we'll let that go.
So, jokes, fine. But, this, somehow can go through space and hits the electron and makes it go like this. I mean, it's just nonsense. Can't do that. This is how you push on something. I push on the medium. The medium compresses in front of my push. That compression is sent to the other electron and causes it to move this way. So I move an electron this way, the next electron moves this way. That makes sense. This other crap is crap.
And here you can see the emitting and receiving electrons oscillation.
So there he just did it again. So he has a bunch of little arrows, pointing in a direction like this direction. And they just keep pointing in that direction while they go this way. So they're going this way at the speed of light. And I don't know what, they're not going this way at any speed. They're just pointing in this way. So somehow he made a piece of field that's pointing this way and going this way at the speed of light. So the whole idea that the field could hold two different motions, that it could have a motion this way and a motion this way, is nonsense. But yeah, it's just, it's nonsense.
Is perpendicular to the expansion of the wave.
So again, it's just nonsense. If they just redrew it and just said, look, okay, this electron pushes out into the field. The field is coming in, hitting it. Obviously, if I have 10 bullets, 1 second apart, and I push the surface, they're going to hit into them, and now they're going to reflect. Well, if I go half the speed the bullets are traveling, then the bullets are going to be twice as close to each other. So they came in an inch of space between the bullets, and they're going to come out with a half inch of space between the bullets. That's what the frequency of the light is. It's just about how quickly you did this and how much you compressed the field.
There you can see with your own eyes
a completely ludicrous animation, okay? Fake illustration, nonsense drawing.
all the conditions required.
So what condition? There's no field, there's no mechanism, there's just some idea that electrons create some sort of ooze, and then when they go like this, that somehow their ooze vibrates and just keeps vibrating as it leaves. So it's oozing something, it's excreting something, and somehow the excretion keeps doing this. And then when it hits another electron, the excretion doing this is somehow going to make the electron do that. Not a chance. That play button didn't work. Try this one.
To go from an EM wave to producing the interactions that we currently call photons.
So it's really not producing anything. All right, so maybe I will break in with my usual breaking in. And just try to say, look, what we see as a photon is what's received on a surface. And what has to be received on a surface for us to detect a photon is usually something called electricity. So you basically have to hit in an atom, an electron that's part of an atom. That pressurizes the atom. So the atoms push on each other with their electrons. That means the next atom has electrons that are moving. And now you push on that atom. And now they're going to move even further because you've added energy. And then you say you do it a third time. So you hit it with a third particle within a frequency that's the size of the atoms. You could understand that, yes, one atom gets pressurized. The next atom pressurizes a little more. And the third atom pressurizes enough to push the electron into the next atom, to actually cause the electrons to be displaced. All right, simple definition of electricity. And the reflected photon is just the byproduct of doing that, where you use the energy. That is, you push out against the field. So if the atom's pushing against the field, you get a photon going out that way.
Because light waves are emitted by electrons.
So okay, light waves are emitted by electrons. The argument I would make is, look, you could come up with a theory that electrons and protons are actually excreting a force. And that's all that's in the universe, is the electrons excreting and the protons excreting. So they have to be some sort of energy source. But that's not going to create the pressure that creates gravity. That's not going to create any of the other atmospheric kind of conditions that keep atoms together. Obviously, atoms are compressed together. Something has to be pushing them together. So I think it's much more rational to just accept that, no, there's already a whole bunch of this energy in the universe. It's already pressurized. It's already full of air, so to speak. And everything has to be built to withstand the air pressure like we are. We don't notice it, but we're kind of high pressure machines.
And detected by electrons, the point-like interactions we have mistaken for a particle are actually just discrete events from the electrons.
Discrete events from the electron in the form of some field for which you give no description or diagram for how it's constructed, what the hell it's made out of, how the hell it does any of this stuff. Nothing. So no mechanical field, just some sort of magical field that keeps arrows that go like this. It's a field full of little arrows that can do this. They can go the speed of light this way while they're pointed this way. But they don't go this way. No, they just point that way. I mean, it's just magic. There's nothing real to this.
And there you have it. There is no need for wave-particle duality.
So he's got the whole premise, and this is basically the cornerstone point, that somehow electrons and protons, by jiggling this way, create a speed of light motion in the field that goes this way, as if it was a surface wave on the ocean, which you could sort of understand because that's a complex construction, right? I mean, you push the force in, the pressure gets too high, so it has to go out where there's less pressure. It can't go down because the ground isn't going to be compressed, so it has to go up because that's the only place that's compressible, the air, the atmosphere. And then gravity and the atmosphere are going to take care of it and push the wave back down again.
Or wavicles, it's just EM waves producing discrete events.
So just EM waves doing some magical thing where you jiggle something over here in the swimming pool and something over here starts bobbing up and down, or inside the water. Let's say you're underwater. Again, surfaces cheat. And so they're kind of saying, look, it's like a surface wave. Well, the field can't be all surface. You're going to have to account for how the field can make this consolidation in pressure. And the easiest way to do it is this. Just simply state that if I have a field of discrete balls in space with an average distance between them, every single time I push out, I'm going to compress their distance. Every time I push back, I'm going to expand their distance in terms of their reflection off the object.
But I have one more thing.
One other thing.
Those animations I showed don't really prove my second condition that I described.
So he had some animations done by his daughter. Very nice little, idea of, waves coming off of waves coming off of, But it's crap. The waves have to be going in the force, the energy has to be going in the direction that's going the speed of light. And that's, and vectors, these are vectors. It can't be three-dimensional. They can't have 3 dimensions of motion. They're vectors. They can only move in one direction. They can't move in 2 directions or 3 directions at the same time. Photons can't do that.
That the emitted electron must produce a full wave of motion. How do we know that's true? Well, that is...
Well, you don't, and that's the truth. All right, figure I better draw some of this just to be really clear, all right, on what I'm arguing versus what he's arguing or defending. And again, it's a nice enough guy, all that kind of stuff, but this is just, it just doesn't make any sense. So I have an object and I move it up. Okay, what's going to happen? If it's excreting its own field, what's going to happen to that field? Well, the argument would be is the intensity of the field in the direction you're moving it would obviously be more intense, right? More stuff, more little dots. So if it was excreting little dots, you could understand it's going to be more dots in that direction. So the most intense energy is going to be going in the direction you're actually moving. That's where more dots are going to be. And if it's a field that's reflecting, you could understand, yes, obviously you're going to compress those dots the most in this direction. And then every tangential direction is going to be a little less energy. So it's like pool balls hitting each other. You understand that the more slight the angle at which you hit it, the less energy you impose. So the motion this way with a round surface, okay, is going to create some energy this way, but it's going to be less energy because it's more tangential. So all of these tangential bits of energy are going to be less and less and less. So that's the true diagram of what the pressure wave would look like, is that it would be narrow. A cone that would be kind of narrow. It could be extremely narrow, I would argue. All right, it's not going to be a circle. Okay, it's not going to be any of that kind of stuff. And clearly, as it moves through space, this moves through space, this moves through space. There's nothing that's going to go this way and convey to another electron that it's supposed to go up and down. There's no energy that can do that. There's no part of the motion that will be sending anything, any signal, straight perpendicular. Straight perpendicular, like I said, you can sort of understand it in a swimming pool. If I'm doing this up and down thing, there's just no way 10 feet away, some other thing is going to start going up and down. It's just not going to happen. And the only way it could possibly happen is because of the creating the surface wave. You know, I'm doing this, I'm creating a surface wave, and the surface wave will create some motion, but it's really not going to convey it through the mass of the water at all. So you might see it on the surface, but you're not going to see it anywhere else. So it's just very deceptive for them to say this motion up is retained here, 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 here. That somehow upness is still there, and somehow it's traveling this way. There's no energy going that way. So how could it be traveling that way when there's no energy that way? You haven't changed anything that way. This, moving my hand up and down, is not changing the energy going that way. And that's what you have to do, is change the energy going that way. All right. I think that should help with providing an understanding of the point I'm making. All right, continuing.
Is implicit in the very equation of a photon. As you can see, we either use the frequency or the...
So why would we? Okay, you're saying this is the definition of the energy of the photon. I'm going to argue it's the definition of energy in the whole context of kinetic energy, or this argument that somehow bullets have more energy than recoiling guns, when no, they just distribute energy differently. So they distribute over a shorter period of time because of the higher velocity. And generally speaking, bullets are small, so they hit a smaller area. So they impose all of the force in a small area in a short time, but it's the same exact amount of force or capacity to move matter. And the same thing is true for photons, is that you're just really saying by changing the frequency, I can disturb electrons more because I give them more momentum quicker. So let me draw that one too. Yeah. All right. So let's say I wanted to move an electron from point A to point B. Okay. If I hit it slowly and it's in tension, so it's connected to a proton, okay, you could just sort of understand that, yeah, I hit it, it moves a little bit, and then it's going to move back, okay. So it's not going to be able to leave. And so if I hit it once a day, okay, then all it's going to do is move a little bit, move back. If I hit it faster, and then faster, and then faster, that is, if I take my 3 baseballs, my 3 units of energy, and I distribute them very quickly to the electron, then before it starts reversing direction, that is, while it still has forward momentum, you hit it again and you extend the arrow, and then you hit it again and you extend its momentum. Then you can understand how it's gained more energy because you distributed the force over a shorter period of time. Oh, definitely got to fix the focus thing. Always something. All right, so good enough. So this is like a tipping point argument. I've made this argument for years, blah, 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 blah. I don't know if I want to do it again and again and again. But anyway, so it's clearly, the quicker you can get velocity into an object, the more velocity you can give it. And then in any friction it is in, there'll be less friction the faster it's moving. So the faster you can get something moving, the less friction it's going to endure, because the less time it's going to be affected by the frictional force. So if you can reduce the amount of time the frictional force has to act on it, you can reduce the strength of that friction. And so fast gives you an advantage. It doesn't mean you have more energy. It just means, okay, that you've applied the energy in a way that's more effective to traveling a further distance. Now, continuing again.
Wavelength of light to deduce its energy. You can't have frequency and wavelength without oscillation. Okay.
Right, and so the fact that something might be oscillating isn't an issue, in the sense that obviously things in pressure or in tension can be forced to oscillate. The point is in which direction is their energy, the direction they're oscillating in, or some other direction. And I'm obviously arguing that no, the energy is in the direction of the oscillation.
Now, you math heads might be yelling at the screen because well,
I mean, I can't swing a pendulum 10 feet away and then have another pendulum over here and it starts going. That is not going to happen. Where if I did have them linearly connected, then you could get some idea that yes, this pendulum could be pushing on a force that would cause the next pendulum to start oscillating. So that's a coupled oscillator. So if I have any kind of rubber band or medium or string or something to couple the oscillator, I can create that motion in the direction of the motion, but I can't create it in the perpendicular direction. I'm not going to create any energy in the perpendicular direction. So that just won't work. Sorry.
Well, I can use math to take even the slightest sliver on a graph and deduce or extrapolate a full sine wave. But it doesn't mean it's physically there.
So, I mean, it's nice that people do this production thing, make videos, blah, 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 but I wish they would just make videos without resorting to the gimmicks of psychological imagery and all of that crap, because that's just for psychological purposes. It's playing a psychological game, trying to humiliate math by, making a cartoon out of it. When you can defeat math by merely pointing out it's a crude approximation of an elemental function. It's a formalization that is supposed to be more efficient than dealing with all of the variables. You just put the important ones in. So in theory, it makes perfectly good sense. 2ness plus 2ness equals 4ness. It's a nice, clean statement. To take the idea of its, what's the meaning of this? Well, you could say it's flesh. You could say there's a length. You could say lots of things. But the 2ness is the thing you're formalizing. You're saying the important thing is this 2ness part. And if I take two 2nesses and put them together, I have 4ness. That's how math should be thought of, as a simplification. You're just trying to grab the essence of something and put it in a formula. Okay. And they just think it's actually the universe is mathing. And the universe isn't mathing. The Mr. Rogers thing over here on the wall is interesting. He's been coming up a lot lately. I still don't get it, but I like it's friendly and nice, and he talks to he has his little scared part of his personality, and has the brave part of his personality and the obnoxious part of his, I get all that crap, but still, it's still creepy.
The electron can't do math. It can only respond to physical changes.
Right, and that's the whole point, because I would argue to you, is that if you really think about what the electron is doing, it's doing nothing but being moved by a field. The field is deciding where the electron is, and what the electron does affects the field on the other side of the electron, you could argue. So electrons are just conveying information it's allowing the field energy to interact with the field energy. The field can't interact with the field. The photon can't hit the photon. But the photon can hit the electron and cause the electron to create a new photon.
So if it is going to respond to a light wave and produce its own EM wave, it has to physically move.
So yes, obviously. So I don't know anybody who thinks they don't physically move. And clearly a particle theory would involve moving electrons. I mean, throwing baseballs that you collect the momentum of. So baseballs in space. And you're really just saying that you're throwing these baseballs around, things can collect them or they can reflect them depending on which way they're going. So if I'm going towards the baseball, I reflect it. If I'm going with the direction of the baseball, I can collect it. So I can take my speed of 10 miles an hour and turn it into 20 miles an hour if I collect 2 baseballs, and 30 miles an hour if I collect 3 baseballs, that kind of idea. So I can increase my speed by collecting more baseballs in the same direction. But every time one hits me from the opposite direction, I'm going to reflect a baseball. That simple mechanism satisfies the evidence in terms of an explanation for what you see.
It can't just do math. I will die on this hill. There is nothing wrong.
I don't know what that means. Never even heard that expression. Is that something like with your, I have to pry my gun out of my cold dead hands and my anal vibrator. Yeah, that too. You have to pry that out of my hands too. Lube. Lube's important. I have to pry that out of my hands too.
With using logic and reasoning in science, math should be for describing our reality.
So again, it's not describing, it's modeling with as few pieces as possible. That's what math is. It's a model made out of infinitesimally small amounts of information about the system. Tiny, tiny bits. You're trying to just say, what's the essence of it? Let's put it in a mathematical formula. It's a formalization of the essence of something.
For verifying assumptions, but not for creating reality.
Yes, well, again, the math doesn't do that. The math is usually something they contrive to suit their theory or defend their theory. So they're not making a theory out of the math. They're defending a theory with the math. So they're just contriving it. Like Einstein contrived his insanely complicated field equations to do one thing, and that is explain why Mercury's a little bit out of sync with the rest of the planets. And the sync is tiny, and it's only because, well, his field equations are basically moving the sun. So if you jiggle the sun, then you can jiggle Mercury. And Earth and Venus and all the other planets are too far away to get jiggled. That's simple. And that's all he did. 6 months contriving a mathematical pile of crap to force the math to fit the environment he was obligated to explain. That's the truth of it. It's all just contrived bullshit.
Okay? In this case, the nature of physical oscillation is absolutely implicit in the observed measurement.
All right, so again, this oscillation is this is sort of bullshit. He's calling this the oscillation when the oscillate. No, this is the frequency. This is how you create an on and an off and an on and an off, oscillating this way. And you don't need this to oscillate. You just need this to push out. And if the next guy pushes out and the next guy pushes out, well, then you have a frequency and a polarization. And those are two things that photons have: frequency and polarization.
And observations of light. Again, we know this because of radio waves.
So again, radio waves are really, they really illustrate a lot of things. So radio waves, I do the double slit experiment with radio waves, 2 antennas, and then I just move a third receiving antenna between the two, and I can get on, off, on, off, on, off. No interference, no blah, 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 blah. No superpositions, no entanglements necessary. Okay, so it does sort of prove the point. And then the whole idea of an antenna. What happens with an antenna? The electricity moves up the antenna at the speed of light. So it pushes on an atom, it pushes on an atom, it pushes on an atom, it pushes on an atom at the speed of light. So you end up with a distance. So you end up with a pushed out electron, then a pushed out electron, then a pushed out electron. Photon.
Radio waves are also EM waves. The biggest.
So EM, again, we're stuck in this. You should have, this idea of saying, well, let's critique their physics and say, does it really explain anything? And say, okay, no, it fails. So let's go back 3 pages. No, you need to go back 10 pages. I would argue you need to go all the way back to Newton, because frankly, everybody else was a wavist after Newton. And they broke everything with their MV squared and, their whole, the Young experiment and the completely preposterous conclusions they drew based on it, that somehow the photon goes through both slits and all that kind of horse shit. So, yeah, you really have to go back and start over where they started going way sideways to re-straighten the line. Newton and Galileo and Descartes gave us a lot. And, they ruined it all. They gave us a nice mechanical momentum averse. And they decided to go with this silly squared velocity crap.
Difference is that while light is typically produced by, again, atomically bound electrons. Radio waves are produced by pushing and pulling electrons up and down through a conductive medium.
So again, what's the difference? Pushing up and down? I don't know. So no, the fact is they're pushing. The pushing part is the essential part. Obviously, the going back part is creating the empty part between the frequencies. So all you're saying is I have 10 things in space. They're going to hit something. If I push into them, the 10 things are a ½ inch apart now. If I push away from them, now when they reflect, there's going to be 2 inches between each one. So I'm expanding and contracting the distance between the bits of force, you could argue, and creating the frequency that way. So you have a carrier frequency, and then you have the frequency on the carrier.
That's why the amplitude of radio waves are very large and the amplitude of light.
So let's just understand the frequency is gigantic, okay, the wavelength. So it's just this preposterously insane idea that you have a 10-mile long photon. That doesn't make any sense, that this up and going down again thing happens over a 10-mile period of field changes, and somehow that's going to jiggle something. I mean, it's just too silly. Come on, let it go.
Waves are very small.
The idea of 2 birds being 10 miles apart makes perfectly good sense. The idea of being 1 bird stretched over 10 miles makes no sense at all.
Okay, but if you're still not happy with that as an explanation...
Yes, I'm not happy. It's really not complete. It's not any improvement. Get the wave crap out of your head. There's no ether. This isn't about... I mean, the patterns are really important, but they have to be understood that you can make a pattern with bullets. Not only can you draw pictures with bullets, right, pixels, you can have a pattern, a Morse code in how you send the bullets. And so, yes, there's lots of places to have patterns. Understand them as patterns. Don't understand it as waves.
So why an electron requires a full sine wave of motion.
So again, more nonsense about a sine wave. The sine wave, the fact that the electron moves quick and then slows down and then starts to speed up and go back the other way and then overshoots and then, like a regular rubber band oscillator, it's going to have to take some time to be to lose its energy to the field, so to speak. So yes, it goes at a high velocity and then stops. So it has to be gradual, but that's not a sine wave.
Just because of the equation that we've observed, just because of the math, or any of these other things. There's 2 other very good reasons why we should assume this to be true.
No, there aren't. Okay, so your first reason sucks, and the rest of your reasons will suck too.
First is an electron orbits the nucleus.
Wrong. So way off. All right, so I would just say again, the magnetic model works so much better. So if I just had a south-facing magnet in the middle and I put 4 north-facing magnets equidistant, you could understand that if I put that under a plane of glass, so the magnets can't flip, they can't do anything except feel each other's force, that I can't push on any one of those magnets and make them head for the plus in the middle, the south pole. They can't go there because the north magnets are going to repel their motion. They're going to say, no, you can't get any closer to that middle. And it'll just stay just like that. That configuration will be durable. It'll withstand some jiggling, and it'll stay just that way, because every motion I make with the electron, with the one magnet, is going to cause the other magnet to be irritated.
Of an atom. It's hard to orbit something without a full circle. I realize that our kind of
So blah blah blah, full circles. I mean, we know that orbits are tend to be parabolas. So we're in all kinds. And I'm just saying, the very idea that you could even engineer a speed that would be right for the location and all this stuff, it's just nonsense. How you hit an electron that's moving, more nonsense, especially when the polarization of light is gigantic. It can't be affecting a single electron. So the very idea that your little wave is going to push the electron around in its orbit is just too ridiculous.
primitive solar system model of the atom is not accurate. That electrons kind of inhabit more of this probability cloud.
So that's not right either. We know the probability cloud is in one location. Okay, so the fact is the nucleus is not totally positive. It's just net positive. So it's a 2-to-1 relationship. The neutrons are essentially an electron and a proton. So you have electrons still in the nucleus. And the electrons in the nucleus are creating a tension against the exterior electrons being able to get into the nucleus. They're saying you can't join us because these silly fucking electrons that are still in the nucleus say, no mas, you can't get in here. We're already in here, you can't get in here.
But it doesn't take away from the fact that they still are around the nucleus of an atom. But
around is really different than being in a specific location. Obviously, I would argue the whole molecular theory falls apart as soon as you start moving these electrons all over the place. And the only way you could actually share an electron is the electron has to be in one location for two nucleuses to be sharing it. It's in one place. It is not figure eighting and doing any of that horse shit. Sharing means what it says. It's a ridiculous model. The orbiting solar system model is garbage.
even more so, there's the fact that, and this is really cool, waves have inertia. If you've never thought about it before, it sounds counterintuitive.
It sounds ridiculous, okay? They don't have mass, you know, in a sense. So that has to be pushed. So we're talking about the energy itself. And again, we're just saying about how you're applying the energy. The only thing that's unique about the photon is how it applies energy, not that it is energy. The energy already exists in the field. The whole universe is full of it. That's why it's all fucking gravitationally compressed. All right? It's because the energy is, the space is full of this pressure. And all you're saying is that I put a signal on the pressure. And when I put a signal on the pressure, it's able to cause effects. Without a pattern, no effect. With a pattern, an effect. So you're just basically arguing if I throw random baseballs at a stick, I can't knock it over. But if I throw the baseballs as the stick's wobbling in sync with the wobble, I'll add energy and knock the stick over. And clearly, if I just hit the stick with baseballs much closer together, I'm more likely to knock the stick down. Because I'm going to keep hitting it as it's falling.
When we think of something having inertia flying through space in a vacuum, it makes sense for it to go in a straight line until something stops it. It's very easy to get your head around something.
So again, what does that have to do with your your animation of a bunch of arrows that just keep doing this? That's not what you simulated. You didn't simulate a nice ray of force. You simulated some sort of herky-jerky thing that somehow keeps going in a direction but never goes in that direction.
Spinning and continuing to spin in space. But the truth is waves also have inertia. And that is because waves are comprised of vectors and circles. A wave...
So whatever that means, vectors and circles, just mush. You can't have force that has two momenta. A photon can only have one momentum. The force can only have one momentum. It always goes just the speed of light in one direction. It can't go the speed of light this way and the speed of light this way. Can't happen. Doesn't happen. No evidence that's how it works. I can't move a flashlight this way and create photons that come out that are still going with the flashlight. They go out and they go straight where the flashlight was. They don't keep going with the flashlight.
Wave in the end is a complete circle. A sine wave is a full 360 degrees. And it is required for that.
I mean, this is such a tiny connection, to sit there and say, well, look, the orbit's a circle, and therefore the sine wave is a circle. When you put two sine waves together, you get a circle, blah, blah, blah. I mean, and it's not even really true, frankly. It's not a perfect circle.
That inertia to be communicated from one thing to another to complete the full sine wave in order for the...
So that was just bullshit, right? I mean, there was this idea that the wave hits and somehow gave this electron more momentum and spun it out of one orbit into another orbit because it gave it more momentum. No evidence of that. And even their whole understanding of the energy of an electron, they think the outside ring is the high energy ring, and they think the inside ring is the low energy ring, when it's exactly the opposite. It's really hard to get something knocked out of the inside. It's really easy to knock something off of the outside. So the outside is very loosely held. That's where the magnets are very far apart from each other, very little force. Where the electrons are close to the nucleus, lots of force holding them together, lots of force you have to overcome to knock them out to a lower energy level. Play.
That inertia to take place. Otherwise, what you are going to...
So whatever this, again, he's using this word inertia for no good reason. Inertia is just another word for mass. It's the difficulty to move something, and obviously there's no difficulty. You just have to provide energy. If you don't provide energy, it's not going to move. You provide energy, it moves. There's no resistance to motion. I don't resist winning the lottery, you know. I don't have $1 million because I resisted having $1 million. No, I'm not resisting at all. Give me the $1 million and I'll take it. Thank you very much. Please. Anyone with $1 million you feel like giving away, yes, I like it.
To communicate to the other object is...
I'll receive it without inertia. Okay, I'll apply no inertia to it.
Not going to be a wave. And that is the best evidence we have to know.
Oh, bullshit. So that's, he calls that good evidence, and it's a crappy, illustration, moving illustration, animation, okay. Yeah, like animate, completely fake. Animations are completely fake, okay? They're not real.
That if we're talking about a wave communicating its information to another object, that information has to be completed through a full sine wave of motion.
All right, so again, there's just no sine wave created. I drew it for you earlier. The energy is really basically going in one direction. It's just nonsense to say that somehow the up and down motion is being conveyed at the speed of light this way. There's nothing to convey it. There's no mechanism pushing that way, so it's not going to go that way.
So an electron can only re-emit a full sine wave of motion if it received a...
So this part is sort of true, okay? The idea that one electron affects the other electron affects the other one, but it has to push in the direction of that electron. It can't just perpetuate some magical field and the electron's creating a circle. No, the atom's creating, you could say, a circle, because there's an electron on this side and an electron on that side, and I poke this side, I poke the other side. So the electron is pressurized. The electron can convey information, but it's all straight line force essentially, and there's no reason to believe in any of this mush. Electron communicates with electron by pushing on the field in a direction. The other electron feels that push. Push works. Pull is nonsense. So come on. It's a push-averse.
Full sine wave of motion. Okay, but one more thing.
One more thing.
Team switching off.
Yuck. Stealing Columbos. Yeah. Yeah, we all have this impulse, I guess. I sort of want to steal South Park and Homer and, steal all the icons. Have Frankenstein do something, all kinds of, But it's just, cheating. I think it's cheating. All right, so after the commercial, he says, I said before the shape
Shape of a photon is more like a rectangle. So now, if you put everything...
Right, so this part is really useless. So I don't know exactly what he was trying to accomplish with this. So we'll play some of it, but it's just so weird because he's just telling me, oh, look, I take the card this way and I bend it this way. It's a smaller amount of card that you see. It has smaller spatial dimensions. Well, that's true in the sense that you can understand the pushing argument is that argument. I push fast, I'm going to really compress it. I push slow, I'm just going to compress it a little bit. So, all that can be understood. But how do you use this card in, what's it matter what direction the card turns in space? It just couldn't make any difference. So I don't understand the point of it at all.
together that we just talked about. The shape of what we call a photon fits more accurately within something like this.
That doesn't have a frequency, though. So I'm just saying you need more than one of those lumpy things to make a frequency. They have to be at a distance, so to speak. You have to have an event, and then an event, and then an event to have a measurable frequency. You know, so you're just basically drawing a big giant thing again, a 10-mile long card. So you're just saying the length of the card is the length of the frequency, or the wavelength. And yeah, duh. So you're saying photons are really long things and very narrow things. So, that doesn't really help any. And again, we know that with photons of light, the polarization is consistent with the wavelength. So, and it kind of really shows up with radio and antennas. The antenna length gets consistent with, so like microwaves, 3 centimeter antenna, radio wave, 10 meter antenna, so your polarization is consistent with your change in frequency. So again, this card thing doesn't really work because obviously the photon of a radio wave, it's going to be gigantic polarization.
Because on this card here, I have a full sine wave represented. And what we now know is that this wave has to pass by the electron.
So this idea of passing by is bullshit. Obviously something has to hit something. The photon is not charged. It can't do anything. It can't do anything but hit. It has to hit to cause an effect. And it hits with a quantum of energy, as Einstein stated.
Completely from beginning to end in order for it to communicate the wave.
So can you imagine a 10-mile long radio wave hitting a single photon? So the radio wave has a gigantic polarization. It's 10 miles long, which means it takes quite a while to finish getting somewhere. And you're saying it's going to pass an electron, and the electron's going to do some kind of motion that's perfectly consistent with something that is 1,000,000 times bigger than the electron itself. Your card is a 1,000,000 times bigger than the thing you're going to interact with. It's just no chance. No chance. Nonsense. It's either it hits or it doesn't hit. And it's just a clump. The clump hits something or it doesn't hit something, period.
So that means we have our height, the width. I'm going to put a big asterisk on. We'll get back to that later. But that's basically it. That's the area that creates an effect that we call a photon.
Now, I would argue that photons do travel through space with an area, in the sense they have polarization, and then they have the how many units do you need. Now, I would argue you need at least 3. That photons aren't just 2 bits at a distance, because then the frequencies would be all over the place. Like just random things could create a frequency. So it's probably 3 bits that need to hit in sequence with the right frequency, the right distance between them, for it to be actually a red piece of light or a blue piece of light. There has to be 3 units that are consistently at the right distance. That means you have 2 units of distance. 3 units of force, 2 units of distance.
It's a rectangle. Now, here's where we get to the really cool part. And this is where the evidence for this occurring starts showing up in all of the math and all the experiments that we...
So all of the math doesn't mean much. So let's just talk about all of the experiments. And so he's, we're 18 minutes into his video. He hasn't described a single experiment yet. So we'll see what happens.
We have when it comes to photons. And that is the concept of a projected plane. So here's how a projected plane works. So this card I'm showing you right here, if I'm holding it perfectly straight at the camera, you can see that it's 2.5 inches by 3.5 inches.
So this part, like I said, I don't see how this makes any sense at all. I don't see what purpose this has. I mean, he's trying to describe the difference between a red photon and a blue photon by turning the card. Yeah, obviously if you change the frequency between events, yeah. But there's no card turning. Photons aren't turning. So it's just, what the fuck are you talking about?
And we're going to call it card 0, okay? That is the plane of the card, but it's also right now the projected plane. In other words, this is in 3D space right now. And if I hold it like this, the area...
I think I'll just speed this up, frankly. Right, so I'll just play it through because, you know, it doesn't mean anything to me. It doesn't mean anything, so...
area that matches perfectly with the physical dimensions of the card. However, if I turn the card a bit, now the projected plane, the surface area of the card that you see, is less. So the equation to now understand what the area of this projected plane is to you is, we have our new plane, card 1, is equal to card 0 times cosine squared 45, 45 being the angle of which now I have tilted the card. I'm going to take card 0 and I'm going to multiply it by cosine 45. The area now of the projected plane is 4.375 square inches, okay? And again, it's called projected because I'm taking this from a 3D world and I'm limiting it down to your 2D world on your YouTube screen. Okay, now, let's say we're talking about this card, you know, again, representing the sinusoidal EM wave from our emitting electron. In this case, we're showing just one card equaling one wavelength. Now remember that in the case of light, we can't have just any wavelength because the other part of the equation here shows that we have to have a wavelength that falls into a certain quanta, which, you know, extremely small quantity, in this case, the Planck length, that's what the H means. This is both the term and the concept that quantum mechanics is founded on. So to understand this H in our equations, what you need to do is you need to think of the C as like a ruler. That's the full length of our ruler. And the H is notches in that ruler. So this means our wavelength needs to be able to go from one notch to another notch. It has to meet in those small, tiny increments.
All right, so this is just bullshit in the sense that this is not how the quanta work. So it's just a certain amount of, like I said, these are clumps. So you can't have a half a clump. So you either get hit with 4 clumps or 5 clumps or 6 clumps or 7 clumps. It's always just a clump, and you can't change the clumpiness. So all of this is not how it works. And we know that the frequency can be any frequency. So if we know there's not, the frequencies don't clump. It's not like you can't have, you know, 467.78689102 whatever, 14 frequency. You could have any number of a frequency, and that's legal. So the frequency isn't clumped.
But if I were to...
I mean, photons can travel in any direction and at any frequency. Just like I can shoot bullets out of a gun at 1 second or 1.000000000, you know, forever seconds. You know, I don't have to. There's no obligation to quantize the frequency. So this is just wrong.
Take that same wavelength and now tilt it just a little bit. There's a good chance now that I'm falling not on those notches, but between them. Due to the nature of an atomically bound electron, something which I can't dive into yet in this video, it is impossible to produce a non-quanta of an EM wave.
All right, so this is just bullshit. The the frequency of the wave is not quantized. The energy is quantized. All right, and the energy has absolutely nothing to do with the frequency. The energy is always the amount of stuff hitting, and again, the appearance of more energy is not the reality of more energy. So the fact that the electron is more disturbed when you apply the energy quickly than when you apply the energy over a longer period of time shouldn't fool you into thinking, oh, it's about how much energy it has. No, it's about how you apply the energy. And I'll take this speed thing off. Well, leave it just a little bit faster.
All the waves it produces have to fall within this predefined quanta of wavelength. However, in free space, I can take this quanta constrained wave, which I'm representing with the card, and I can tilt it just a little. So even though my plane...
So it doesn't mean anything. In free space I can do it, but I can't do it when I hit the object or whatever. No. Again, the frequency is not quantized. The thing that is traveling at a frequency is quantized. The elements of the mechanism that's transferring the frequency, that's quantized.
Playing card may obey the rules. The emitted electron produced a quantum bound or a quanta increment of a light wave. In free space, I can twist that a little bit.
I don't even understand how you would twist the element of a photon, so even that doesn't make any sense. So I don't even know what you're talking about now. You're not illustrating this idea that first you have this wacky wave bouncing up and down, and now you're saying that somehow I can turn the wacky wave as it's going up and down. Now I'm turning it in some way, but it doesn't go in the direction I turned it. So it's going up and down for no reason, and then it starts turning in directions for no reason. I mean, come on. This is way far away from being at all coherently reasoned.
So that creates a problem, and that problem is that an electron is basically a point in space. It's very small, itty bitty teeny tiny.
So it's again more bullshit in the sense that obviously we're doing a lot of interacting with them, so they can't be all that hard to hit.
We have estimates of how big an electron is, but we don't really know. Its size is completely theoretical at this point because it's too small for us to measure.
Well, I don't know. It seems a stretch to say it's impossible for us to be able to say how much density does the atom have. And again, so the only way they do this is by sending energy through matter and seeing how much the energy bounces back. Yeah, I don't know how else to state the density versus the force pushing it. So once you know how big the force is, I guess, or how dense the force is, then you can know how big the objects that you're moving with it are.
So all this is to say that this wave emitted from one electron going to another pretty much has to be communicated within line of sight of one electron to another.
Well, yes, line of sight means straight lines, means rays. And again, that's where this whole thing is just nonsense. You're trying to make rays out of energy going in all directions. And so if the energy was going in all directions, you'd only be getting a tiny percentage of the energy in one direction. Again, so this whole bullshit theory that somehow the energy went everywhere in the universe, in 360 degrees. It went every single place, but only landed in one place. I mean, that's the crap of quantum mechanics. I mean, it's just absolutely a silly explanation. And why should that be the default belief when it's the silliest explanation?
In other words, it's really impossible to graze an electron. So that's why they have to be lined up so perfectly. What that leaves us with, going back to...
So they don't have to be lined up perfectly. They just have to be able to see each other. Period. They're reflecting force at each other constantly. So they're always aware of each other's presence at the speed of light. And they're very close together at the speed of light. So they're getting updates all the time.
To our kind of, thinking about the pictures we painted at the beginning of electron moving.
So again, this is the bullshit animation where the arrow stays going in the same direction. It never goes in that direction. The force just moves this way, saying, I'm this way force, I'm this way force, I'm this way force. And it could go a billion light years saying, I'm this way force, I'm this way force. But it never goes that way. I mean, it's a ridiculous animation.
And producing an entire expanding sphere of change to the electric field, we are left with a ring around the sphere that is parallel to the emitting electron.
So it's just silly to say that photons work this way because we know the energy is real that's conveyed. And like I said, you're talking about 1/1,000,000th of the energy of the event, if you're going to spread it in all these directions. So there's no way you can have energy going in all those directions. You're not going to receive photons in those directions. That's the absolute fact. So why are you pretending it actually goes in those directions? Because it doesn't.
Can communicate light from one electron to another. That's right. Photons are rings.
So this again, no reason to believe that happens, that has anything to do with ringing. Okay, it's bad enough you're waving and now you're ringing. No. So the fact is, the electron is you could consider that a sphere or a round thing, and the fact is that you can add pressure to its electrons, and that pressure will be interpreted as an expansion. But the trick is, if the electrons are under pressure in a direction, then they're going to only expand in one direction, so they're going to shape change. So you put energy in this way, and they get fat. No offense, but they get fat in this direction. Yeah.
Why did no one...
So it's perfectly consistent with what we know about electricity. Electricity goes this way, and the field goes that way, the energy, because you're basically just pushing on round things, turning them to oval things, and the oval's pointing that way. You're pushing that way, even though you push this way on the atoms.
One tell New Jersey drivers about this new...
Oh, poo. All right, should be back. Commercial science.
Hold on, that's true. Around every emitting electron, every electron that emits a light wave, there is a ring of potential photons. And I use that term with big scare quotes.
Yeah, I like the words, though. I like the idea of bits that can become a photon if they arrive at a surface at the right location at the right time. So that part I'm okay with. The idea that there's broken pieces, okay, and lots of broken pieces. And that you can make a photon by having energy from one direction meet energy from another direction.
Okay? It sounds absolutely weird. We've never been taught that. But if you look at the 3D models that the math produces, like in 3 Blue 1 Brown.
All right, so this is terrible, what the math produces. There's no math in this century that could be possibly understood to be real or have something to do with reality creates this. Something that moves the speed of light this way that somehow has a vector this way. So it's moving the speed of light that way, but it has a vector this way. Nothing. That's not real. That's crap. That's the definition of crapomatics. Okay, that's invented for the purpose of illustrating what you're illustrating. Okay, you just created math, invented some idea that something has a vector in this direction when it's not going in that direction.
You look at the equations that we have for expanding EM waves, it's all there. It's
not all there. That's just crap. So sorry. Bullshit, bullshit, bullshit. Contrived, forky thing nonsense.
I don't know. Even though we can literally 3D model it and see it right in front of us, we don't see it. But the truth is, light waves are rings.
So again, he keeps saying it, and then he's going to try to contrive in a way that you can somehow use this silly... The photon is creating energy in all the electron is creating energy in all directions, and somehow, though, it turns into a laser beam. Bullshit, it does.
I mean, they're spheres, but the area ring around the emitting electron as it expands is the place where another electron can be stimulated and re-emit another one.
Well, obviously, the chain reactions between electrons, like a chain reaction of neutrons flying out of an atom and causing a nuclear bomb, it's all mechanical. They have to hit each other. It's just bullshit to say it isn't about momentum and exchanges of momentum. So poo on this nonsense.
Wave. I got to say, this realization was probably my favorite part of this whole project. The fact that when we're talking about one...
So again, it's such a terrible realization. Your idea that somehow something has a vector in a direction and it moves this way is just a terrible physical notion. It's just so nonsensical.
Electron, and we'll talk about why it's only one in a minute, oscillating produces a ring of potential photons. Once that sinks in, it is amazing how many things that affects, and we're going to go through it.
Yeah, like I said, this is so much smarter. Just understanding there's a field. The electron's going to push into it. It's going to reflect a whole bunch of stuff sooner than it would have because it's moving closer to the objects it's going to reflect. So it's going to tighten their frequency. So much more intuitive. So much more sensible.
Light and optics, even in what we call entanglement. All of these things start having an underlying intuitive explanation.
No, there's no way you can turn entanglement into anything but wooey, religious spirit bullshit. There's no mechanism for I see you without light or any physical mechanism. I see you. I don't even have to stick my tail into your tail. I don't have to do any. I see you. Bullshit you do.
Just with that understanding. And by the way, I will give credit. My editor was the first person to figure that out.
I don't, which is his daughter. Okay, so, so, his daughter's growed. Okay, so, guy's a little older than he looks probably, or else he fornicated way too early. Anyway, had a kid in high school or something. People.
If an emitting electron produces a ring of potential photons, why don't we ever experience that? Well, that's...
I don't even know how we could experience that, so it doesn't really make sense. But yes, the element of a photon is just saying I'm compressing the field. And obviously all these compressions have to add up to hitting a surface in just the right way to create a photon. So the energy's always hitting everything. And all we're really saying is sometimes we're going to send the energy with a frequency, and the energy is going to cause effects that the energy wouldn't cause if it wasn't at a frequency. The carrier is doing the pushing. The frequency is making the push happen in different amounts of time, which means it's going to break the glass or not break the glass. So the pressure is already there. All you're doing is creating an oscillation in the pressure. And that oscillation in the pressure is what's going to break the glass.
For several reasons. The first one is because the only way you would experience that is for that ring to hit two electrons at the same time.
Right, which is perfectly understandable in the sense that you could have pressure from one frequency where you're moving an electron at twice the momentum, and you could make two other electrons move at half the speed. So that's just a pool ball thing, right? I hit the cue balls going 10 miles an hour. I hit two balls that are next to each other, and I make both of those fly off at 5 miles an hour. Perfectly sensible.
And given the conditions we just talked about, that's incredibly hard. But it does happen, and we'll get to that later. The other reason is...
So that's just the crystal thing doing the conversion of blue light into two red photons.
Because as this ring expands, most of the stuff in our world isn't arranged like that. You know, it's hitting flat or jagged surfaces. So as that ring expands and hits, like, let's say, a flat surface, it's going to hit at different times depending on where the ring is.
And again, there's no evidence that photons are constantly separating out, that the wave is changing shape as it moves distance. The photon that travels 1 billion light years is the same as the photon coming off my light bulb, at, a meter away. So there's no evidence that anything's spreading over distance for the discrete photons themselves. They are discrete, and as Feynman would say, they're clumps. And you're just changing how much distance is between the clumps. That's the dilution. Is just a matter of changing the distance, but the photons themselves have the same energy. You can't dilute the energy of the photon, you can only dilute how much energy is in the field total.
But finally, the biggest reason why we seldom observe a light wave as a ring is because we mostly observe light in streams. And this is the other
So that's, again, bullshit. I mean, the sun isn't a stream in the sense that, yes, there's clearly a part of the sun that seems very focused right on us, but, the atmosphere is diffusing the light and sending photons from all kinds of different directions. And then light bulbs are multi-directional. So, again, there's lots of examples where we can understand that it's a bunch of different rays pointing in different directions. But it's rays. It's momentum. Momentum has a direction, a vector, and it only has one for especially the force itself. It can't move two momentums. It can't go this way and this way. One-dimensional objects. It's made of rays, if you're going to call it something. It's a ray of light, not a wave of light.
Critical thing for you to get to understand light. When you hear science YouTubers, like the chart we showed, or the thumbnails that we showed before,
So he kisses up to most of these people. Okay, so the 3 brown, 4 blues guy And, he even links to the Veritasium shitty one photon experiment that's bullshit. And whatever, the other minute physics, junk videos, blah, blah, blah.
About light, you will notice that they are very careless to confuse the idea of a single photon with lots of photons. And it is a...
So why don't you play an example of that? So I don't know if they're all that careless. All of you are wrong in the sense that what you're saying is a photon, is something that's traveling through space and hits a surface, because the slit experiment is basically proving to you that the photon is going to be made out of influences from different surfaces, and two different surfaces are going to send information to a location. And if I just send it from one surface, it's not a photon. But if I send it from both surfaces, it's a photon. So clearly the photons don't even have to be in spatial same dimensions traveling in a straight line. It can be straight lines of a bit from one place and a bit from another place. So photons are what arrive at a surface. Photons aren't what travel through space. Bits of a photon travel through space. Photons land on surfaces.
Big difference. Beams of light, as we know them, like lasers, or when we're doing experiments with refraction, what we think of as light going in a straight line isn't a photon going in a straight line. It's lots of photons that produce a coherent wave in a line.
Yeah, it's just saying that basically it's heat in one direction. There's lots of ways of describing it. It's just heat all moving in the same direction. Yeah, and it works as a description. It's momentum, and it's moving in one direction. If I have momentum in all kinds of directions, then it's not very effective. But if I have momentum in one direction, it's going to be effective in moving something, making something happen.
And again, I'm going to refer back to the 3 blue 1 brown video. As you can
again, so these are all fake arrows just moving through space like this. And now he's going to do the double fake of saying somehow the little arrows bang into each other. So two arrows, two pieces of force, two photons essentially hit each other at these angles and then come out this way. That doesn't happen anywhere in real physics. So again, this is just such nonsense. None of this happens in the real world. This isn't a real world example because it just doesn't happen. There's nothing mechanically can do what they're describing here, and it's all synthetic and holy ghosty. They're just saying, I have a holy ghosty thing that has a vector in that direction but moves in this direction.
You can see here, if you align the oscillating electrons up, one next to the other, the waves along the sides cancel each other out.
And the whole thing doesn't look very consistent anymore, right? So we know how coherent the laser is, and the energy levels. Look how one clump looks brighter than the other clumps, looks brighter. It's very inconsistent. So it doesn't look anything like what we actually see in terms of the reliability of the density of photons hitting a surface.
Now you get more or less a coherent wave going out from the front and the back.
And only because he's basically saying I can make the force hit the force. I can make a photon hit a photon and then go in the different line. And we know that photons don't hit photons.
Those electrons. And this is the majority of the way we experience light.
So it has no way it has anything to do with anything real. It's nothing I experience. So bullshit. And another fucking commercial. Ah, it wasn't a commercial. It just looked like one.
Lights, TV screens, you name it. The only time we really...
Yeah. The straight line force explanation works just fine. It isn't broken in any way. Understanding it as rays of light coming off the sun or rays of light coming out of a light bulb. It fits the inverse square law perfectly. It all makes perfectly good sense. The little rays are coming out and they're spreading in distance in 2 dimensions. Inverse square law, 2-dimensional spread. Yeah, all of that works great. So how do you explain the inverse square law with your wave going in all directions theory? Exactly. I mean, rays make it really easy. So I'd be interested to hear how your clump of wave creates an inverse square law when it's the same equal potential in all directions without turning it into discrete bits, without turning it into rays. Let's see you explain the inverse square law.
don't experience light like that is with a good old-fashioned classic light bulb just sticking out of a socket. It's easy for us to think of light going.
So it's really easy to look at it and point out how, well, yeah, it's really just a bunch of lasers in all directions. Lots of ways to understand it. The light being shown in the other direction is because it's pointed in the other direction. Yeah. Not hard to figure out at all.
In a straight line, because most of the time we experience it, it is. But where this gets troublesome is when we confuse in our experiments a stream of light with the idea of a single photon. And we
All right, so that's where I would argue too that that's where all the bullshit lies. This idea of ever creating a single photon, that is a single bit of energy in the field, that you can't ever do. There's no mechanism for making a single photon. It just can't be done. We don't have any hardware for that. All right, so I guess this is good enough as any place to stop, or an hour and 20 minutes, which is way longer than I thought I'd go. But anyway, it's impossible really to do a thorough job without it taking a while. So I probably will come back to this. I'll play the rest and see if I can find a key point where he says something completely where no way I can't ride on that boat. I'm sure it's coming, and maybe he'll get to the experimental evidence and we can see how well he documents the actual truth about what the experiments produce as evidence. And that's really what we should be doing, is interpreting evidence. All right, so till the next time and such and so forth. So a lot of photon videos coming, unfortunately, or fortunately, depending how you look at it. Like I said, I like this guy, all that, no offense meant, blah 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 blah. Maybe he's willing to have a conversation, but it looks like he's just doing the production video bullshit, and that'll be the end of it. But frankly, if he's willing to make unlisted videos, maybe I could pay him to make a response video. So we'll see, and I'll just play it on my channel. Anyway, till the next time and such and so forth and whatnot.